data and ideas. I will present some of the work we've been doing on detecting alterations in fresh fruits and vegetables as soon as possible in order that we can take decision about those before it's too late. In the last decades, there's been a growing interest on non-destructive approaches to evaluate quality. And, there is a number of advantages with that, both in terms of, experimental application and also in terms of commercial applications on that. And among them, those who use optical approach are the ones who are more, let's say, successful, more applied. It's related to the way the material reacts when it's illuminated with some source of light. So spectral response and imaging combined together most of the time give a number of informations, and those, of course, depends on the characteristics of the materials. Most of the time, it's just a surface, especially when you work in the visible range or wavelength, or it can be also related to composition and to what's going on inside the products when you're going into the near-infrared wavelength. So spectrophotometry has been applied a lot. Together with imaging, you can have much more information. It's not just on where you apply the light, but in this case, you have a number of different images, a number of different information related to the surface as well. So you have what you call the hypercube, where the number of information available, which are related to both external and internal features of the product, it's very high. Lots of work in the recent years has been done on correlating spectral information and composition, and there is a lot of machinery already in the packing houses which can grade according to both external and internal features of the product. So we can tell what's inside, and we can also tell where things. We can map according to the spectral response. But indeed, if you look at the data, there is a lot of other information that you can extract from this huge data set that you usually get out from applying spectrophotometry imaging. So I'm going to show some of the results we've been getting in the last few years in our lab, especially with relation with physiological alteration, but not only. Alterations both in terms of physiology and pathology are, as you know, among the most important causes of losses in fresh produce. And fresh produce is one of the type of food where losses, post-harvest losses, are very high and can reach a percentage of the harvested product, which is dramatic. Some alterations only become visible when it's too late. They usually start from inside, not necessarily, but very often. And, if there was a possibility that you can detect early before the alteration become too bad, let's say, there is still a possible of reversibility. So we can change conditions and make sure that the alteration doesn't go on, or we can, at the worst, just remove that fruit or that vegetables in order to have better quality, final quality with the customers. This is the work Sandra Munera did part in our lab and part in IBIA's lab in Valencia. And, this is a typical application, so what you can make with it. So in this case, in the first approach, fruit pixels were classified, if it was detected of sound, part of the fruit. And then the second approach classified the defects into internal and external defects. And then the third approach, you could tell one defect from the other. So it's a kind of way you can have a lot of information. You can decide what to do with that fruit. So some of the most frequent defects during the post-harvest phase of fruits and vegetable life are often originated to, let's say, not optimal conditions during storage. And among these, chilling injury, which is a disorder which is related to temperature, especially low temperature, but above freezing point. So chilling injury is completely different from freezing injury. So water status is still liquid, and there is a number of fruits and vegetables which are sensitive to these conditions, and usually comes out with a number of different symptoms. Internal browning is one of those symptoms. This is an application we did on eggplants, which is very sensitive. So we stored eggplants at two temperatures, chilling and non-chilling. You can tell from here, I don't know if it's, I think maybe this way, I don't know. Anyway, yeah. You could tell from traditional, conventional approach what is chilled and what's not. And in this case, you can see how we could predict how many of those fruits which were in chilling condition were going to develop chilling injury even after 2 and 4 days of storage. And even better, we could predict the fruits which were stored at chilling temperature compared to the fruits which were stored at non-chilling temperature. The same data, a more recent application with zucchini, which is another commodity, which is after 3 days we could tell with a very good accuracy the fruits which were going to develop chilling injury during storage. This is another application we're doing. In this case, it's not related to chilling, but to anoxic conditions. There are dynamic controlled atmosphere applications which are based on sensors that in some way tells you when fruit are switching from aerobic, let's say, to anaerobic conditions. We're trying to apply spectral information. So fruits were stored at a different level of oxygen, 0, 1, 0.5, or air. You see different amount accumulation of secondary metabolites like ethanol and acetaldehyde. Very good correlations between acetaldehyde and ethanol concentration in a descriptive way, and a very good discrimination. These are just preliminary results, but you can discriminate fruits which have in some way been stored in anaerobic conditions. Last thing I want to show, this is a much simpler application. It's based on conventional imaging, so we're talking about photos taken with the camera and visible. And the idea is that we want to see how we can, discriminate a product according to freshness. So this is a normal visual scale that we apply usually to evaluate. So this is what experts do in order to evaluate the quality of the fruit. We saw if a computer vision system could tell the quality in terms of freshness, and it did it very well. The other thing is, can it be applied on the bag with the plastic? So if the thing could be, and another thing also, which is very much related to freshness, is the accumulation of ammonia, which is a very good bioindicator of freshness. So the idea, you can tell here that correlations are very good both for packaged and unpackaged, for chlorophyll and ammonia. and different types of products, from soilless to conventional growing. And our idea is that, when consumers buy the salad, they can put under a camera and tell the amount of freshness, and they can choose the bag if it's good or not. That's a very nice application. Actually, what we're doing, we're trying to make it on a hub, so you can do it straight with your cell phone. Last, reducing the number of information to elaborate. Make sure that the execution time of the algorithm it's much, much lower. We passed it from 25 milliseconds to 3 milliseconds, just selecting the best color pick. I switched the conclusions, and I'm just there. Thanks for your attention. Take 30 seconds for this announcement. This is the Spanish and Italian post-harvest working groups meeting together in Palermo in September, but all of you are invited to participate in this. Thanks a lot.
Thank you, Giancarlo, for this nice presentation.
Any question? Or?
Yeah, yes, one question, so there's time for one question. Well, there's one there.
There's one.
So,
good morning to everyone. Congratulations for your result. My question is related to the limit.
To the
limit, the deadline to define if something is good or not, no? Depending on the market, or is related to the edibility. Because from my side, I can see this, the value of this technology, but maybe we are doing something that we could increase, for example, the level of food waste. If, for example, I am buying something and maybe the level of freshness is not very good, but it's still suitable for the human consumption. So maybe I am going to discard this instead of. So I don't know if there is some kind of deadlines, let's say, for the market and for the edibility, for example.
In any case, in the case of the final application, you're giving more freedom to the consumers, but we're always talking about edible stuff. So it's not too bad not to be edible. So the thing you can do is, instead of leaving at the distribution chain the opportunity, not to take good care of the produce, because they don't care. It's just if you buy it, it's okay. Otherwise, they return it to the producer. In this case, they are forced to keep best conditions in order the product to stay fresh as much as possible. Otherwise, it's the distributors that is selling stuff which is not good. But I think the interesting application, it's ahead in the chain, because if you looking at the storage methods in terms of dynamic conditions, like they do with controlled atmosphere, they adapt conditions according to responses in real time from the fruits with different kind of sensors. They do it with oxygen levels. You can do it with temperature, for example. So there is a certain time you can go back with temperature and make sure that the produce is not damaged for life. And that's, I think, it's very interesting in order to reduce losses during storage.
Okay, thank you.
Yeah, there is time for one more question, small one. Actually, I have one for you. So also connected to the idea of the question of Hector. So it's also connected also to your answer. So I think apart from the fact that you can use these technologies at home just to check quickly that what is the freshness of, I think it's also the applicability to the whole food chain. So where you can just get information in real time, how is the freshness of the product. So it means this information can also provide some clue to the managers just to do what they have to do to reduce the food loss in that case. So what is your view about that?
Well, that's, I think, our main concern is that you know, for many fruits and vegetables, the chain is very long, can last months. So during this month, there is a time limit when things are, they went a little bit too far, so you cannot go back. And so the only thing you have to do is discard. They are not good. So if you know ahead of time when things are going on, and you still are able to make changes in terms of, you know, environmental conditions, so you can try to reduce the incidence of chilling injury, of anaerobic, of scald, or whatever, and try to reduce losses during the chain. So I think the applications, you know, in controlled atmosphere storage, they are a little bit ahead of time because the technology is a little bit more sophisticated, so they are investing more money into that. We're trying to do that for that application with a different sensor. But I think it's very important to do it also on much poorer storage technology like cold storage, which is indeed very important in terms of inducing alterations in the post-harvest phase.
Okay, thank you.
Okay.
Okay, so let's go with the second speaker. It is Prof. Tan Phat Hun. He will present for us the electronic nose for monitoring volatile organic compounds.
Hello. Yeah. So thanks for invitation. So then I can have a talk today about my work is mainly chemistry, and I try to find like a topic that can highlight, for example, the food perspective in my work. And one of them is the electronic nose for monitoring the volatile organic compounds. But during preparing the presentations, I also realized that actually I have some more connection with the food, so I will tell it in the next few slides. And for our friend who asking about the Åbo Academy University in Finland, so actually we are in Turku together with the Turku University. So the Turku University, they are the Finnish speaking university, and we are the Swedish speaking university because Finland is the bilingual country. Yeah, and next is that first is the connection with the food. So then I just realized that's something that I work with my student for developing the tool to teach the high school student chemistry and electrochemistry. And the student, like, she quite interested in education, so we create a project that she do for the high school student. So here is that she want to develop some new kind of maybe interesting tool that over there you can see the electrochemical process, like when you connect, for example, the copper wire in a pan into a battery. So either on both sides you can either generate the hydroxide or the proton. So the hydroxide will give the basic condition and the proton will give the acidic conditions. But the thing is that when you have the indicator, for example here, connected with food, extracted from the red cabbage, that someone yesterday also was talking about the anthocyanins. And they are the quite fun indicator, so they can change the color with the pH. And but the thing is that usually you prepare them in the solution. You know, it's hard to demonstrate. Either you use spectroscopy for that. So for that, like, we think about a substrate. And then the substrate, the hydrogel, that formulate with that anthocyanide in the Petri dish. And actually the hydrogel is another food product, the carrageenan, that extracted from the seaweed. So then it's simply then the student, they just connect the pen with the battery and then they draw onto the surface of the hydrogels. Yeah, so they make some logos or some kind of art here. So yeah, we have this kind of report in this article. And the second thing is like some ambitious work that I try to do with some colleagues from Estonia and other countries. Like we try to apply some funding for Horizon Europe, but got rejected several times. So we just tired and then publish a review. So there, like we together with other plant physiologists. So we're trying to develop, this similar concept to electronic nose, but for monitoring of the plant health. So the plan is that, for example, if you have the plant grow in a chamber, so you can monitor the microclimate of the chamber, for example, the humidity, temperature, and other things. But we also have expertise who work on the stomata of the plant, so then we can see whether the VOC and other gas molecule that release from the stomata that we can monitor. And so overall we can have a complex data, but maybe we can find a fingerprint how to, like we can see the condition of the plant. So that was the idea. And in the review also I found that some people in USA, they already prepare some wearable devices, for example, that they attach on the plant leaf and monitoring the methanol, for example, to see the condition of the maize. Yeah, so briefly, there are many type of sensor, but this one is just the chip only. It's not a device, but it shows the mechanism of the sensing. Like either you can have the material that put on the electrode, like the yellow kind of comic. We call it interdigitated electrode. So you can measure, for example, the changing of the conductivity, or you can measure through the change of the mass. For example, when you have the material that put on the gold electrode or the quartz crystal, so you can the material can absorb the gas molecule, and through the changing of the mass, because they have the addition of the gas molecule, so you can have the changing in the mass, and also like some color change, similar to our previous speaker talk about the spectroscopy. And not yet electronic nose, but then I found another connection, because we prepare now the sensing material, and actually I just remember that we have done with wagam. And the wagam is the polysaccharide that extracted from the wasit. So we didn't do any extraction, we just bought the wagam polysaccharide from Sigma. So what we do is that, like you can see that the wagam, they are polysaccharide, they are not conductive, and we work with sensor. So we need to do something with that. So there is a bit chemistry. So there is the polysaccharides here. You can see the OH, but then there is a X in the blue. Is where we did some synthesis, like we introduced a new group. It's called like xanthate. So if you know roughly about coordination chemistry, it's just simple. Like if you have some group with the free electron pair, so they can coordinate very well with the transition metal. For example, here we use copper. And the most interesting thing is that the copper, when you turn it to copper sulfide, so it's like a conductive materials. And now it worked for us. And then, for example, the last picture of the sensor chip is the material that we prepare for our research. And because the polysaccharide is the hydrophilic, so they are very good for monitoring, for example, the polar solvent, and here we just go directly with water. Relative humidity, response of the sensor, and they are conductive, and then we can also put on the very small picture over there is a paper-based substrate. So you can prepare the sensor on the paper as well. Can be from food, paper. And yeah, so then you put the material, and then, for example, we put that sensor on the finger, and then you just bend it, and then you can see the monitoring of the strand, we call. And they are quite stable. You can see that it can go for a long period of time with many cycles. Each up and down is one kind of moving. So for that is not some. I will talk about electronic nose, but it's turn out it's not like contain all the topic that I work today, because I also found something that I mentioned before is also interesting to mention here. But anyway, electronic node is similar to our node. It's like array of the sensor. It's just not one sensor like what I showed, but it should be the array. And then if you want to have the nice features like with big data and cross-reactive between sensors, so you need to prepare in the different, for example, chemistry for different sensor. And using the multivariate data analysis, for example, someone yesterday also do the principal component analysis. You can also discriminate the volatiles. And yeah, there are some commercial ones. So, for example, we work with the conductive one is here, but you can find also other work, for example, with the chromatography mechanism or photoionized mechanism. So quickly, for example, this is the field effect transistor. And for example, here, if we want to recognize, like, for example, different type of silane. So they are just silane, but the thing is that they are isomer. They are in the different position, like over there. And this is the conductive material, and then you deposit. And the easy thing here is that, like, based on the feature like came from the field effect transistor, you can go with different feature like mobility, the response of the current or something, and then you use that as input to recognize the patterns. And yeah, so also we can use an array of sensors based on paper together with my colleague. So we can also do similar to what I mentioned before for plant monitoring. Like you can also do with not only the chemical response, but also physical response at the same time, like temperature and humidity and other things onto the light. Yeah, so that I see how because from this is not actually my work. I just help the people here to characterize their product. So I didn't do this kind of work. But to join the course, because I'm also thinking about the food waste and other things. But on the other hand, I just remember about this kind of work that I collaborate with the people in Norway, and they formulate the film for the packaging for the chicken fillet. And they formulate like different kind of like chemistry for the PLA with different gas composition for packaging. And then they found the best compositions for packaging. But I'm thinking also maybe, I don't know much about the field, but if you can monitor the condition of the gas like inside the packaging, maybe it's also good to prevent the food waste. Yeah, so for that I finished my my work, my presentation today, and thank you. Yeah.
Thank you for this very interesting presentation.
Yeah.
We have time for 2 questions. Any question? No, so we can progress with the other presentation. Thank you.
Yeah, thanks.
So the next speaker is John Taremel from Tarsus University, Turkey.
Yes, hello everyone, good morning. I am Emel Yontar and I am Associate Professor at Tarsus University in Industrial Engineering Department. So, sorry. That's okay. Today my topic is assessing the potential of digital twins in food supply chain to reduce food loss and waste. And my presentation contents is here. I will start main aim and introduction, then I will mention the research question, and I will explain methodology, and last section is implication and conclusions. So the study's aim is to investigate the possible potential factors actually of digital twin technology in minimizing food loss and waste in the food supply chain. So what is important? Food loss and waste. Of course, all of us, we know this, but we should focus on the numbers again, maybe. For example, 17% of global food production is wasted, and 103 of produce in supply chain is lost, and 303 billion tons of carbon dioxide are released due to food loss and waste, and this process is responsible for 7% of greenhouse gas emissions. So these data clearly shows us the economical and environmental dimensions of food loss and waste is really important, actually. So to overcome these challenges in this section, actually digital technologies, digital transformation is maybe a solution. Like that Internet of Things, blockchain, artificial intelligence, and also digital twin technology has gained to real-time monitoring and operational optimization in food supply chain. So what's food supply chain? Food supply chain is an actual process. So it's beginning the production to ending the consumption. And it includes agricultural, harvesting, storage, also cold storage, transportation. In food loss is include from production to consumption, but food waste is mostly consumption is related with, but sometimes retail section is important in this part. My studies research questions has 3 questions. So one of them is, what are the important factors that will require digital twin technology to be included in food supply chain to reduce food waste? The second one, how do the potential factors of digital twin technology identified in the literature affect each other? And finally, what are the implications or recommendations for using digital twin technology in food supply chain? Digital twin technology is a virtual representation of the a product in supply chain management, real-time tracking or monitoring or observing anything else, and it's also can be used to simulate, predict, and optimize the performance in the real data. So it is provided by using the sensors like the temperature sensors, pressure sensors, humidity sensors, reflect the state in the real world. This is a digital twin example. We have one real world, we have one digital world, and it's combined actually digital twin technology. So if I say another example, for example, let's say fresh fruit and vegetables are being transported from farm to market, and with digital twin technology, actually we can use the sensors, and in which sensors we are collected the data, and after the data we can show the spoil and spoil time, and we can optimize the logistics process in digital twin technology. There are so many benefits of digital twins in minimizing food loss and waste. For example, real-time monitoring and transparency, reduce the uncertainties, and optimize inventory and logistics and related with inventory management. and improve traceability and food safety. Maybe we can integrate blockchain or machine learning integrated digital twins enhance the food traceability. Last but not least, predictive analysis and scenario simulation is the another benefits. In literature review, so many studies actually topics on the cold chain optimization, end-to-end supply chain visibility, quality traceability, and the main challenges of digital twin technology. Despite of these advantages, actually there is a little early stage in the benefits or adoption in food supply chain in digital twin technology. So this study aims to evaluate the K potential using the Mattel method, which is widely used multi-criteria decision making. And the Mattel method is used to determine cause-effect relationships, and it has 5 steps. First step is creating the direct relationship metrics, and the second one, normalization. And the third one, we obtain the total relationship metrics. And fourth one, calculation of sender and receiver group. And finally, we reach the importance weight. So in this study, I reached the 11 criteria of digital twin technology in food supply chain. What are they in here? DT1, DT2 are codes for this study. And visibility and transparency, flexibility, risk awareness, efficiency, food safety, traceability, collaboration and coordination, digital cold chain operations, food supply chain performance, real-time problem detection, and fast decision-making process are found based on the literature. And then the Mattel method is used in this section. So in this part, this is a relationship metrics. We compare each other, each criteria other by its own for this table. So, for example, visibility and transparency affect, for example, flexibility criteria high influence because its score is 3, but flexibility affect visibility and transparency just very low influence. We understand all of the and we compared all of the criteria each other. And then the Mattel steps are applied in order, units. And finally, we reach the table, final table. This is the last table actually and so important. So this column in here actually shows us importance level of weight. And the other, the last column shows the affecting and affected criteria for us. If it is scoring is negative, so it's classified affected criteria. If it is positive, it's classified affecting criteria. So we can look at the cause-effect relationship. 4 criteria are cause group. The 7 criteria are affected group because it includes negative scoring. So what are they, affecting and affected criteria? 4 criteria, visibility and transparency, traceability, digital cold chain operations, and real-time problem detections are affecting criteria. And flexibility, risk awareness, efficiency, food waste, cooperation and coordination, food supply chain performance, and fast decision-making process are affected criteria. We understand in here visibility and transparency has the highest impact value, and efficiency and food safety are most affected in the other criteria. So we can say that visibility, transparency, and cold chain operations if increase, so food safety and efficiency also improve. This is another diagram for is a relationship map. This we can understand in here how much criteria related with another. For example, DT1 and DT6 are not targets of the arrow signs, so we say visibility and traceability are not affected in the other criteria, but they are affecting. So implications: increasing visibility can be a key strategy for reducing food loss. Affecting factors and 4 factors is really important to increase the performance, and real-time problem detection directly impacts decision-making process and operations, and effective management of cold chain operations directly supports food supply chain performance, and transparency solution can increase risk awareness, collaboration, and efficiency. Finally, as a result in this study, we can say farmers or food processors can increase food production, improve food safety, minimize food loss, so they can use the digital technologies. And thanks to digital twins, real-time data can be obtained at every stage of the supply chain and help predict risks. And the biggest impact, visibility, transparency, and traceability, and it can improve cold chain operations tracking and food safety, preventing spoilage and loss. So, thank you.
So, Emel, thank you for the presentation. We have time for a couple of questions. Any question in the audience? I have a question.
Okay.
So, I mean, I'm really a believer of that the digital twins is the path for improving the food logistics and also many other things like food safety, quality, and also reduce food waste. We have some experience with some companies also implementing these technologies. But one of the bottlenecks that we find is the computing resources what we have. So we need to manage a lot of data. So what is your view about that? Because it's true that theoretically, when you just design prototypes in your lab, in your dry lab, so it's working well. When you have one piece of fruit or one couple, when you have a small lot, when you try to scale up, into real conditions, so you find that you have millions and millions of data that you have to process, and you have to also couple different kinds of models. So at the end, you have a very big thing that is needing a lot of resources for computing that. So what's your view about the future?
Actually, we can use digital twin technology, not all of the food supply chain, maybe part of the supply chain, for example, you said the logistics, so not one by one the maybe food, but maybe they can use the package and integrate it with RFID technology or artificial intelligence, not actually just using the digital twin technology. We can, in my opinion, we can integrate it to another technology, like that, the blockchain technology. If they can use these all of the compacts, so the company has a very much performance for this.
Okay, thank you.
You're welcome.
For your answer.
Can I make a comment on that? Because you talk
Yes,
about big
yes,
data.
we talk.
That's quite interesting. Data is not a big issue in digital twins because there are a lot of new algorithms and there are a lot of physical hardware available. I mean, they are quite expensive, but if you can purchase them, they can resolve. The biggest problem that you have now with digital twins is to model the human side. That's the biggest problem that we have because humans are not predictable and you cannot make an accurate digital copy of human. That's where the problem is. You can make a very accurate digital copy of a factory, but not a human.
Maybe, yes. The company is maybe related with this digital twin technology, not the customers.
Okay, so thank you for the answer, for the comment. So let's just.
Last but not least, now we have the next speaker is Prof. Wang. He will present for us applying system thinking on reduction of food loss and waste.
Lost? Okay. Okay. It's always a daunting task to be the last one. Most of your material has been spoken by previous presenters, but I'll try to enlighten most of you by some of the details. Dear Chair, dear colleagues, dear President, thank you very much for inviting me, and it is my pleasure to share with you some of my research in recent years regarding food loss and waste, especially with focus on systems thinking. I'm Professor Yi Wang. I am professor in University of Bedfordshire, which is about 20 minutes with train from London. We are one of the unique university in the sense that we are very sustainable. We was awarded Queen's Prize for Sustainability and Green University of UK for 2 or 3 years, and we were ranked as #1 in the Sustainable Higher Education Institution. So I'm based in School of Business. My day job is looking after most of research in the business school. I'm also head of digital analytics lab, which we just started with the funding from government on £500,000. So today I'm gonna present a little bit about my research in agri-food and waste management, and I've been doing this for past 10 years. It's part of my research. I'm also doing other bits or pieces around the operation and business management and business analytics. So today's focus is about system thinking and system dynamics within food loss and food waste. Some of you might already have seen some bit of it from the Macedonia presenter yesterday. He made a causal loop diagram, which is based on some of the talks that are going to happen in my research. So today's talk, I draw on experience, draw on some of the model that we developed through these projects. So I work both with EU project as well as national and local funding bodies to look at agriculture management, waste from agriculture management, and also food loss, as well as using technology to improve these tasks. Before I go on, I think we need to establish a common foothold where I'm coming from. So from a management perspective, if we look at the prevention of food loss and waste, you can look at from a picture like this. So imagine you have 2 time frames. Time stamp 1, you discover there is an incident, in this case, food loss and waste creation. And then you have time 2, where this incident is ended. So from management perspective, and I draw inspiration from Slack and Johnson. Nigel Slack, most of his textbooks are treated like a Bible in Operation Circle in UK. If you've been to Crowfield, you know most of the undergraduate and postgraduate service operation management course are using Nigel Slack's textbook. However, there's also a small portion who think his work is like satanic curse, but that's a different story. The idea is that if you want to do prevention, that should take place before, or that should start before the incident took place. And what you do is you really manage the risk. So a risk is a probability of an incident that will take place in the future. So it's a probability between 0 and 1. And 0 is that this incident will never happen, 1 is this incident will guarantee happen. Now, during the incident, you want to de-escalate. In other words, you want to reduce the impact of this incident. You want to reduce as much as you can, reduce the time span between T1 and T2. Now, At the end of this incident, a little bit time frame before the T2, you need to start a recovery. So this is what we saw, or what we have as a fundamental for prevention of food loss and waste. From this diagram, we come up with three correlations. First of all, you need to predict the risk. Okay, you need a good prediction system if you want to successfully prevent the incidents. Second, the risk management can never eliminate the incident, can never eliminate food loss and waste. You can only minimize the probability. So you want to reduce the probability. That's why my title is about reduction. So reduction of the probability that it will take place. You can never put it to zero. You can make it as close to zero as you possibly can. The third corollary, or the third statement we can draw from this, is that after T1, you want these intervals to be as short as possible. So you want to reduce the interval between T1 and T2, and you also want to reduce the T2 in order to have minimal evaluation. Often, a company will not survive this, but if they are able to survive, able to recover, then they are doing quite well. So, my study is around prediction. Okay, from my PhD till today, about 60% of my research time I spent developing prediction model, look at accuracy of prediction. So the more accurate prediction you have, the better you can prevent the incidents. And nowadays, the prediction has become more complex because you cannot just look at one system, you look at multiple systems integrated together. So for instance, if you have bioscientific system, you have legal system, and you have human behavior system. These three cannot be dealt separately. It has to be looked at jointly as an overall arching system. And that's where that's where my research is focused. Now you will say system has been around for a long time. I mean, we know what system is. Why do we need to focus that much on various systems? Well, there are a couple of reasons. First reason is that our life has become more complex. Some of you might have heard of Industry 4.0, some of you might have heard of Industry 5.0, some of you might have heard of the Agriculture 5.0 or 4.0. So in our current standing, in this time, most researchers, academics, would agree that we are in a transition from Industry 4.0 to Industry 5.0. In other words, we are almost coming out of the Agriculture 4.0, going towards Agriculture 5.0. So what is this 4.0, 5.0? These are the industrial revolutions. So the first industrial revolution takes place in the UK, where you have mills, where we have the huge textile production, where we have steam engine that roll around with machinery, with train. Second industrial revolution, we have electricity and magnetism that are able to create assembly line and mass produce. And the third industrial revolution, we have computers. The fourth industrial revolution is technology, like Internet of Things, like sensors. They join together to create an automated organization. Okay, so we want to have a factory, an organization with no human, with as much automation as possible. Now, this concept has been achieved. In two places, it has achieved especially well. In port, so there are about 7 O2 ports in the world. When I say O2 port, I talk about automation about 85%. Okay? The other places is warehouse. Okay, there are a couple of industrial warehouses where the automation will reach close to 90, where there's nobody there, there's only truck, a lorry, automated guided vehicle to move product around. But in agriculture, there's also some advancements. So we talk about farming, where you use automatic drones to drop various seeding and to oversee the growing of the crops and checking the waste and to estimate the possible food loss. So there are areas. So we are at a stage here. We are going towards the fifth industrial revolution, which is more focused on human beings. And when humans come into the research, or when you research on human, you find that they are more complex. They are not just one system. You talk about multiple systems, and they need to be integrated together. So that's why it is more important nowadays to think about how can we integrate different systems. And the idea forward, one of the ideas forward, is use what we call system sensing, system dynamics. Look at the dynamics between the system to link them together. Now, systems are not a new concept in food loss and waste prevention. Okay? I think all of you have seen, or you've seen some of these models. Sustainable food system have been existing since 2014, and you will find a huge development of various types of definition or concepts dragging together regarding this type of systems. But the key here is, are these completely different systems or are they the same? There are a lot of similarities. A lot of researchers just add a couple concepts and then they claim they create a new system. So what are the links between different systems? What are the exact links? Are there any consistency between these models, or are they just randomly select model and concepts? The key here, I think some of those who deal with like digital twins and computers know, there's interoperability. In other words, how can these... Okay, how can these work together? Okay, so the basic of system thinking, system dynamics are this kind of, are the symbolic flow. So you can draw a model, or you can draw a very simple model, and look at the input and output, and use a simple or complex mathematical model, or existing mathematical model, to simulate part of this flow. Now you say, this is simple, everybody knows that, we've seen that for 60, 70 years. Yes, but if you combine various of these model systems, you can create a complex system. And you can actually link these systems together. Okay? You can actually link this together. And you can use this system to simulate. In order to predict the future, you have to simulate. So you have different data that you put in, or then you can run it from use different scenario, extreme cases where you have huge huge loss of food, or huge waste creation to absolute no waste creation, or even you can put negative numbers and see what happens. Now, this is fine, and this has been done for a long time. Some of the researchers here are also doing this. This has been going on for the past 20 years, but there are two major problems with this. Two major problems. One's oversimplification. In other words, there are a lot of experts who can make this model, who can develop the relation. You have one group of them looking at the problem, and if you drag another group of experts looking at the same problem, they'll draw out exactly exactly opposite model, or even different model. So how can you make sure that they can agree with each other and not waste time on debating the consistency model? You have oversimplification. So a lot of consultancy on system thinking in food management, on waste management, are oversimplified, just telling you how to do the mapping. And the other part is lack of a consistent expertise. In other words, you might be expert on one area, someone might be expert in the other area. How do you have enough experts to join together? So my recent research and contribution are looking at using data mining. So you have always data available regarding waste management, regarding food, almost done. And you can use data mining to create rules, and you can use a small group of experts to create the different type of system dynamic model, and then calibrate. Okay, so you have some standing point, some non-standing point, join them together to create a more accurate and performance model. And these have quite great results. And due to time constraint, I'm not going to go through each of them individually, but you can read it from some of these papers that we did for these projects. Sorry, I think I ran a little bit over the time, but I'm always open to questions.
Thank you. Thank you. Unfortunately, we don't have time for questions. You can have the opportunity to ask in the coffee break. Thank you for all speakers to give us this presentation to show the importance for smart system to reduce food loss and waste, and we can move to the next session. Thank you.
Should I just leave it as it is?
Sorry, I need your help just to know which one. This is this one? The first one.
Food waste discourse.
Which? This one?
Yes. Thank you very much.
Okay. So good morning, everybody. The last section is about the networking communication. And who will be the first speaker?
Yeah, we cannot have a better way to start this session with a talk from Mohamed Agay, that is the Prima Agrofood Officer Coordinator, that will give us an overview of what Prima is doing for food loss and waste, with the talk titled Innovative Strategies for Agrofood Loss and Waste Reduction, Insight from Prima Agrofood Funded Projects.
Okay, thank you so much, Romanazzi, for this nice introduction. Allow me first, before I start, to congratulate you and Dr. Fernando and Dr. Omarwa for the successful conference that we have here today. So please, let's give them an applause for this success. So thank you so much for the well organization and the hospitality, and also for the visit yesterday to the mosque and the cathedral. It was amazing for sure. I am Mohamed Oghi. I'm the Prima Project Officer for the Agri-Food and Value Chain. And over 1.5 days, we listened carefully to very interesting presentations about the achievements modeling, how to fight against the food loss and waste. So allow me today to tackle this problem, but maybe from the perspective of the policy and the funding agency. So before we start, I don't know how many of you are aware about what is Prima and if you have been involved with or not. So let me just take you like 12 years ago, when the European Commission and the participating states from the southern and eastern part of the Mediterranean analyzed together the common challenges facing the Mediterranean, including the climate change, the global warming, the food insecurity, water scarcity, and other problems. For all those reasons together, they initiated the Prima as a partnership for research and innovation with an overall budgeting around 700 million euro. We have 20 participating states from Europe and from the southern and eastern part of the Mediterranean. We are tackling 4 thematic areas: the water management, the farming system, the Wi-Fi nexus, and last but not least, for sure, the agro-food value chain. So where we stand after 7 years, we launched our first call for proposal in 2018, and until 2024, we managed to fund up to 269 projects with a total investment more or less 400 million euro. But the key indicator that we always love to mention that more than 2,500 beneficiaries, and here we are talking about research organizations, companies, universities, as well as SMEs are now cooperate and co-create together. So I have a question to you. If you have been already involved in any of those BRIMA running projects, please raise your hand. We have some numbers here. So hopefully next year or the next FoodWaStop conference, we will have more beneficiaries. So here are the key achievements of some of the analyzed projects. For instance, out of the 50 completed projects, we have more or less 125 demonstration sites. Most of the developed solutions and technologies reached a high TRL from 6 to 8. So let's now zoom more on the shifting toward a sustainable agri-food system in the Mediterranean, where the food loss and waste is a cornerstone in order to achieve this goal. It's important when you address the food loss and waste to understand the root causes of this problem in order to find solutions to those problems. So here I try to summarize the main problems or the main challenges facing the agri-food value chain in relation to the food loss and waste in the Mediterranean. For sure you know this better than us, like the climate and environmental stress, the high temperature, the drought that we have, the unsustainable farming practices, the limitation or the out of date of the infrastructure that we have, especially in the southern and eastern part of the Mediterranean, the transportation bottleneck, and the small-scale farmers or producers and the market distortion. If we analyze those root causes, we can realize that it is not just a matter of the technological and science gaps, but here we have as well the social dimension that I have to consider when I draft my proposal or my solution, as well as economic and environmental aspects as well. So when I design solutions or a modeling for solving the problem of the food loss and waste, it is important to consider the different aspects related to this problem, because it's a complex problem. That's why BRIMA exists, and through our projects and actions, we are trying to address the different challenges or the causes of this. So this is the philosophy that we have in BRIMA to address the food loss and waste. Is not just focusing on the technological innovation, but also valorizing strategies, policy engagement, so we can have a real impact on the ground and to tackle the problem directly. So for the agri-food projects, we have more or less 86 funded projects, and I can tell that at least 70% of those agri-food projects tackling directly or indirectly the problem of the food loss and waste. We have 11 private coordinators, and this is highlighting the importance of the private sector engagement. And I can tell you that the agri-food sector, out of the other 4 thematic areas, are the one with the highest representation and participation of the private sector. This is something very important. So, as I mentioned, that we have categorizing how we are addressing the food loss and waste. So I just categorized like the 4 main pillars or categories where we can distribute the different BRIMA projects. We have several projects addressing from the packaging perspective, like developing smart and sustainable food packaging that would reduce the food waste, also waste reduction technologies, and valorizing the local products and the byproducts of the process, extending the shelf life of the goods or the food, and encouraging or fostering the sustainable harvesting practices, and last but not least, for sure, the agroecological approaches by improving or advancing the sustainable farming practices to be adapted and mitigated to the climate change, which is one of the main problems that we have in the Mediterranean. I just listed down some of the main BRIMA agrofood projects and also some farming projects as well that address the food loss and waste. For instance, the Stop Mid Waste, which is coordinated by Professor Romanazzi, which is aiming to extend the shelf life. But what is very interesting to this project, that it is not just a matter of the food sector, because also, please correct me, because you are the coordinator of this project, they are also trying to minimize the amount of the energy used in the food processing. So this is highlighting the importance of the Nexus approach. So if we distribute the different BRIMA categories alongside the agri-food value chain, you can see that we are trying to cover the different segments alongside the value chain. But here I just want to underline the importance of something that maybe sometimes we forgot, that the food loss and waste is not just related to the food sector. But remember that we have scarce natural resources in our region, in the Mediterranean, so it is important to consider and to keep in mind that when we are talking about food loss and waste, it is not just we are losing food, but also we are losing water and energy and other natural resources. That's why the Nexus concept is very important to be always keep it on our mind. Finally, I would love to acknowledge and to thank all and different BRIMA projects, especially for sure the agri-food ones that I'm here representing, because they did their best for sure to tackle this problem from different perspectives. As I said, from technological and innovation solutions, from the sustainable and sustainable agroecological practices, also considering the economic policy leverage and to interact with the stakeholders and with the private sector. Last but not least as well, to foster the regional collaboration, because food loss and waste is not a local problem, but it is something like crossing the borders, so it is important to have this international collaboration. Last but not least, again, to highlight the concept of the WEFE nexus in the agri-food sector in general, and in relation to the food loss and waste. This is please something we can keep in mind, considering as well the social dimension, economic dimension, as well as the environmental dimension of this problem, as well as the solution that you are going to develop. Thank you so much for your attention, and maybe, yeah, I'm exactly on time, or maybe we can have like a couple of minutes for any extra questions. Thank you so much for your attention, and wish you all the best. Thank you.
Thank you, Mohammed, for this excellent overview and for investing in providing this challenge to try to tackle food loss and waste. The floor is open for questions to Mohammed.
Nothing. No question. Hope it was clear or completely vague. So
yeah, please, since a lot of people here are working on the area, can you give an idea of not the topic, but more or less what it is planned for the next call, when they will come, and when will be the deadline, and so on? Because I think that a lot of people are interested in this kind of thing. Just in case you can disclose something.
Yeah, unfortunately, we cannot at this moment, but we are still waiting for the green light from the European Commission to launch the call of the 2025. So please stay tuned and keep an eye on the BRIMA social media channels and the website. Hopefully in the next few weeks, very few weeks, inshallah, we will announce the call for the 2025. And I think you will find the relevant topics in the agri-food or in the farming sector related to your excellent work and excellent presentation that you presented over these 2 days. So, yeah, we are waiting for the green light. Thank you.
Okay. Thank you again.
Thank you.
Okay, the next speaker, last but not least, Magdalena Bielanka-Grajewska from Poland. And the title of the presentation, Food Waste Discourse, Current Stage and Future Perspectives.
Okay. Good morning, everyone. First, let me take the opportunity to thank the organizers for inviting me. Okay, now I hope that it works better. I will just open my file. In the corner. Okay, great. Thank you. Okay, today I would like to discuss with you, because we had the opportunity during this event to listen to many interesting presentations about food waste, food loss, and other important issues. Since I'm a linguist and economist, I'm very interested in the communicative dimension of food waste, because I think that it's also very important for us to discuss how we should communicate this issue to the broadly understood stakeholders. I tried to make the presentation larger. Okay, thank you very much for your kind help. Oh, great. Thank you very much. Perfect. Great. I know that we also don't have a lot of time, so I will try to be very brief. And if you have any questions, I hope that we can discuss these issues in greater detail during the coffee break. So today I would like to present, if I can say, the broader scope of my investigation, because I'm interested in the way we communicate food-related issues. So today I would like to discuss very briefly how we can define and classify food waste discourse, and also how we can investigate this important issue. First of all, of course, it's my personal perspective. We can approach this type of discourse, this type of communication, by taking into account the purpose of communication. So why we want to communicate this particular piece of information. So that's why, in my opinion, we can think about risk communication, marketing communication, benefit communication, and sustainable or sustainability communication. Of course, when we talk about food waste and food loss, as we know, we talk about risk, we talk about different models. We also had the opportunity to listen to this sort of discussion during our previous meeting. Also, what we mention very often is connected with care communication, as you can see, with consensus communication and crisis communication. I had the honor to speak about these issues also in greater detail in Ancona during our previous meeting, so I would like to move to the next part. In my research, I'm very interested also in food risk communication, and personally, I would like to investigate, and I investigated in the past, the role of culture of the target audience in communicating information on food risks. So how we communicate and how to communicate in the best way in order to be understood. Also, when we look about different topics that are discussed in literature, as you can see, we have food irradiation, modified food, recall, contamination, foodborne diseases, allergies, food waste, and many other topics that can be also of potential interest to us. Also, I can see some link between food waste discourse and marketing communication. Marketing communication, as we know, is connected mainly with offering, selling products. So also it's connected with, if I can say, advertising, this type of area that can be of interest to many people. Nowadays, it's also very important, as we all know, to be sustainable. So sustainability communication is also of huge importance. Very often when we want to show some aspects, we want to show it to our interlocutors by taking into account benefit communication. Yeah? So it's also very important to show how certain features, how certain factors can create potential advantages for people. Also, in my research, I take into account the type of communication, because in my opinion, it's also very important in analyzing this type of discourse in greater detail. So in my research, I take into account verbal and non-verbal aspects. So how we communicate by words, by sentences, by texts, but also how we communicate by drawings, by pictures, and so on. In my opinion, also it's important to pay attention to the fact that our communication can be literal and also non-literal. So we can use some symbolism in communication, for example, metaphors, in order to be, let's say, more sometimes precise, sometimes maybe more interesting, depending on the way we use this tool of communication. Also, as you know, nowadays it's very popular to use the internet for creating the content, also for sharing information. So that's why communication can be also researched by taking into account of online and offline communication. When we take into account the level of expertise or the level of knowledge, we can think about expert and non-expert communication. Also, in my opinion, when we talk about food waste discourse, we should think about the type of audience. So we should think about people who will get this piece of information. Of course, we can follow the classification that we can find in different articles. For example, you can see the first one in which we can talk about, for example, grocery retailers, policymakers, third sector organizations, sustainability consultancies. Also, I think that we can talk about consumers, researchers, teachers, educators, producers, and other people who are, for some reasons, interested in food waste discourse. Also, what I would like to stress is that types of communication tools and channels, these issues are also very important. So I have already discussed it during presenting the previous slide. For example, metaphors are a very nice tool to talk about discourse and to present different aspects of food waste and food loss. Also, we can talk about mass media, social media, also, of course, articles and books. As far as methodology is concerned, of course, we can find different methods of studying food waste discourse. Here, I just wanted to show some of them. There can be related to the ethnography of communication or the ethnography of speaking, when we want to show also the community one stems from. So not only the way someone speaks, but we want to discuss the community as well. Of course, we can analyze different types of conversation. So that's why we'll have conversation analysis. We have critical discourse analysis. We can also have different tools coming from other disciplines that can facilitate our research. For example, different neuroscientific tools, such as fMRI. Of course, we also have different network theories, system theories that can be very useful. So I just want to say is that when we can, if I can say, talk about the future, or when we can try to elaborate on the potential ways of researching this topic in the future, I think that also the neuro aspect can be interesting, and that's why such domains as neurolinguistics, neuromarketing, and neuromanagement can be also, if I can say, used or even interrelated to discuss this interesting and complex topic. I know that I have no further time, so I would like to summarize my brief talk. That, I know that this topic is very broad and requires a lot of studies and a lot of discussion. I just wanted to show that there are different ways of approaching this topic. Also, that it's really very interdisciplinary. There are, of course, different references that can be that should be mentioned, and I would like to thank you very much, and I hope that we can have also some great discussion on this topic later on. Thank you very much.
Thank you very much. Okay, and do you have any question? Yes.
Very interesting talk. Thank you very much.
Wait.
Thank you very much for the interesting talk. Can you elaborate on how neuromarketing fit into this cost action?
Sorry?
Can you elaborate? You mentioned neuromarketing. I just want to understand how this would fit into this cost action practically on food waste or food loss.
So I think that it can be, but of course it's only my perspective. I think that it can be a start point for us to discuss how also to inform people in an effective way about certain important issues, how we should select the tools that will address different stakeholders. So in my opinion, when we have different projects, when we have different ideas, the communication part is also very important, because first we research something, we have some data later on, but I think that we should also think how to make our research visible, and how maybe to make more people interested in the topic, because these topics are, from my perspective, not only important for us, as researchers, teachers, practitioners, but also for the general audience, yes, for customers, for people who should know also maybe sometimes how to change certain activities in order to become more sustainable, for example. Yeah?
Thank you again. I have a very small question. Are you communicating with your government? Because all of those tools will be impossible to implement without the government help and without the tools of communication with the people, with the audience. Thank you.
So I think that we should always select the tools that for communication that we think will be the most, the ones that we can approach, and also the ones that will be effective in communication. For example, in other types of research, for example, I also investigate how to select the tools by taking into account the target audience. Of course, we have different types of tools when we want to, let's say, speak to young people, and when we want to speak, for example, for people who may not use, for example, social media on a regular basis. So that's why in my talk I also wanted to draw our attention to the fact that, in my opinion, tools should be diverse, and they should also, of course, depend on our also communication possibilities, on how many people we have the team, on our budget, and also on organizations that can help in communication itself. So I think it's a very complex topic.
Thank you. And I know that in your university, I have collaboration with your university. You have a very strong team dealing with the investigation of food, food chemistry, food loss. Do you have any connections with them also? And why you choose this topic? Because your tools are relevant to all of topics you want.
I do not cooperate with, let's say, with the project on food that you have mentioned. So I wanted to look at this topic from the perspective of a linguist. So because I'm not a specialist from the food sector or in the food sector. So my aim was just to provide a general field for some further discussion, also with you, I hope, so that several tools can be selected, let's say, for the future, and maybe they will be more, let's say, or selected in, let's say, in the better way to accommodate the needs and expectations of the target audience. Thank you.
Thank you, Magdalena, for your nice presentation, and thank you for the questions.
Thank you.
Okay, we had a very intense meeting, 2 days with a list of talks, a little picture on different areas of research, and thanks to all the excellent speakers, thanks to the people that display their poster as activities, and thank to all the people that listened and joined the conversation, both with questions and the informal conversation that are very important in such kind of meetings. Now we move to the last part of the meeting. We just heard the importance of communication. So this meeting was streamed online in Zoom, and we had a good number of people that joined online. And it was streamed also on Facebook. So we had also people that joined there, and if somebody of you wants to see again, it will be on Facebook, and we saw some interest. As well, since we saw your presentation and your poster, but we can have a kind of repository on COST website, so you can maybe double check your presentation in case there is, or you want to delete something or fix some, I don't know, spelling mistakes or something in local language or whatever. You can send to the email address costfoodwastestop@gmail.com, and we'll upload as well for the posters. You can, if you want, you can send the PDF to the same email address. So this can be a repository for the people that are here, but also for the people that are at home and had not the chance to join this meeting and are interested to the things. COST is a public project, so we have to give news to all the people, to all the community that funds this kind of meeting. So now we will move to, after coffee break, to separate working group meetings. So it will be a meeting alone, or working group number 1, number 2, and number 4, and a joint meeting or working group number 3, number 5, and number 6. And then it will be a discussion. The VUGI leader will tell which are the activities that are running and are planned within the life of the cost action. And then in the afternoon, we will summarize everything here publicly with everybody. Of course, it will be available also streamed for the people that are at home, and I say hello to all of them. And at the end, we will close the meeting with the meeting of Management Committee. Management Committee is the meeting of the reference of the different countries. So reference of different countries are invited to join this meeting. And when you go out, in case you didn't sign, for your benefit, you may sign. I think that everything was excellent in this meeting, and we have to thank Fernando and his co-workers. So thank you, Fernando, for the very good job.
So thank you, Gianfranco, for the words. I have to say for some housekeeping things that we have now the coffee break in the cafeteria because we have some risk of having some rain. So the prediction was like it was not right the good time to have outdoor the coffee break. So we have to go to the cafeteria, which is in the same complex of buildings, but it's outside. It's not in this one. It's another one. So please. Just follow me and my colleagues just to the cafeteria. And for the splitting of the group, so I recommend that we reconvene here all together, and then also I will ask my colleagues to lead you to the right room, okay? And thank you for coming today. Also, I can imagine that after yesterday, it's difficult to start with so many presentations. So thank you.